Madame et Monsieur, bienvenue. This is the Computer Science 144 video lectures. I remind you of our previous lecture. So we have discussed queues. In actual fact, the past couple of lectures we have discussed collections. So we've started off with stacks and then thereafter queues. I've presented examples of how you would use stacks and queues. I've shown applications. In the case of stacks, we have used the reverse Polish notation calculator we've built with that, and we've mentioned several other examples where one would use stacks. In the case of queues, we've done a simulation of a queue system for a shop, for example, any of the shops that we have. For implementing these data types, we have used either linked list or otherwise we have used arrays. In the case of the arrays, we prefer the arrays that's expandable, the doubling strategy. In other words, once the array is at capacity, we've used all the elements in the array for our elements in our data type, we would double the size of this array and then continue using it, or otherwise if it's full we would halve it at some point, and well, if we don't use many elements we would halve it at some point and then use that. The other implementation that we've used was linked lists. With linked list, of course, we use the concept of a recursive data type or data structure, and we use there the concept that we keep a reference to the first node and sometimes even the last one, and then we link the stuff, the elements together. In the case of the sequential data structures, we have a limitation that the size in a sense have to be specified up front, but we win there by having immediate access, behind having the square operator. If you think in terms of array, we can immediately get to an element. And then in the case of the linked data structures, the nodes and the linked list, there of course the size of the data structure is not known a priori, so it can grow over time. The disadvantage, of course, is that we don't have this index operator, so we can't get immediately to the elements. And secondly, we have to keep track of this overhead of the extra references. Also, interestingly enough, is sometimes in certain applications, especially on embedded devices, it might be problematic to keep these extra references. They waste, in a sense, space. I mean, on a computer like the one next to me or the one that you're using, it will not be a problem. But sometimes there are cases where you don't have enough memory. You can't waste the extra memory for these references. And in those cases, the array implementation is also preferred. However, for most other implementations, we usually pick then the linked list implementation, but it means that there is not necessarily a big winner for the two of them. So what I want to do today is I want to discuss then in this lecture two things. The one will be iterators, and the other one is just some general comments about the work that we have discussed up until this point. So let us start with iterators, and with iterators I'm going to do it at the hand of examples. Rather than having a lot of explanation going on, we're going to use iterators. Now say for example that we have this implementation that we see over there. We have a stack and we have a stack of type string. Now in the case of you have code there where the dots are whatever you have and then code afterwards, but the interesting part is this new statement that we see over there. So what we want to do is we want to print out all the elements in the stack, and the stack implement the so-called iterable interface. In other words, we can iterate over a stack. What do I mean by we can iterate over a stack? Says we can go element by element through all the elements in this particular stack, and then we can print them out or do whatever you want to do them. So the idea of iterators is we want to iterate over all the elements in a particular application, a particular data type. I mean, so just to remind you that we've seen iterators already in the case of arrays. So say for example I have the code int x, so x is an array, and let's say this array has 5 elements. Then I can iterate over this array by doing for int I equals 0, I less than 5, or you could probably write x dot length, I plus plus, and then I can maybe say system standard out dot print line, and what do I want to print? I want to print this x at position I. So what I do over here is I iterate over all the elements in this data structure. And so we want to have the same functionality that I can iterate over all the elements, whether that is now an array as I have over there, or a stack, or for that matter a queue that we have, or maybe at some point a symbol table or a binary tree. In this case, then the iteration becomes a bit interesting, since it's not then this linear data structure that we have, but we will get to this point. And so the code that I have here on the screen now at the moment is I go through it. And so how we read this is for each string s in collection. In other words, for each string that I can find in this collection, and remember this collection consists of strings, and so I want all the strings in this particular collection, I do a print line. Now this for loop that I have there, the so-called for each statement, is in a sense just syntactic sugar. So we actually have another way of implementing this, and this is with the code that I have over there. So what I do is I contain what we would call an iterator, and I get it by calling collection.iterator. So now I make the assumption that my code implements the iterator, can have this function iterator. So remember, when we have these kind of things, it means probably we have an interface somewhere defining that this class promised or plans to implement the iterator function. And I will show you now, but you know already we will use some sort of interface. And then we say while I.hasNext. So somehow this iterator should have a function hasNext, and it will return true if there's still elements in the list. Otherwise it will return false, or not necessarily in the list but in the collection. And then we get the next element in the collection by saying I.next. So the next element we get by specifying .next, and then we print it out, and then we do this while we still have a next field. So this should give you already an idea that two interfaces at play, one that specify the iterator function, and then one that specified the hasNext and next field. And so the first one is indeed then the interface iterable, and iterable is defined in java.lang in the language libraries. So it's a very standard thing. We use the generics here as well, the type parameter, so it is of a certain type item. And what does a class promise to have when it has this function? Well, it promises to implement a function iterator. An iterator will return an iterator over this particular item that I have interested. So now the question is, what is an iterator? Well, an iterator is yet another interface, as I say over there. So it is also in a certain type item, and so it has three functions that it will promise to implement. So hasNext will return true if there's still a next element that can be printed. So in other words, if I have for this array a hasNext, then while I is less than 5, then clearly we have another element, so hasNext would return true. And then the next element is basically this xi, so we have the next element, and then the remove element. Now the remove element, it's an optional method. You can actually have just a blank implementation, that's what we will do, or we will just throw an exception saying we can't use it, since things get slightly complicated, or actually a bit messy to say the least, if you iterate over things and you can remove some of them. So we will not do this in this course, but note, you can do that. You can in fact iterate over a list and remove some of the items. So let me show you then in code in our queue class how one would go and implement iterators. So I open the Q implementation. So now we will have the full Q.java open. And so, first of all, we promise that we will implement Iterable. Iterable being we will implement a function or a method rather, iterator, that will return an iterator on type item. And so we can in fact scroll a bit down. There's all the methods of a queue that you should understand at this point, and then we have iterator there. So it implements iterator. It returns a iterator of type item, since remember we have item specified as a type there, and it returns just a new list iterator. So somehow this list iterator that I've specified over there, that will do the magic of doing the iteration. So we have to implement a list iterator. Now, as in the case of the node, remember the node for the linked list implementation, we used a private class there to hide it from the user, since the user does not have to know, the client does not have to know about the node. Now similarly, a client does not have to know about the particular iterator we're using. It just have to know that I can get an iterator on this. But how the iterator is implemented is hidden to the actual client using it. And as for that reason, we have then that the iterator is a private class. So private class list iterator, and we implement iterator. Remember, iterator is this interface that say we know how to iterate over this items on this particular data set, and we have these functions has, next, removed, and next. And just as a side note, to use iterator, you have to use an import java.util.iterator. For some strange reason which I don't understand, Sun and now probably Oracle have decided to put iterator in java.util and then iterable in java.lang. So as a consequence, you have to import iterator, but you don't have to import iterable. Strange world we live in. So we have here node, and now node is pointing to the current is then the current item to be that we currently pointing to, that we want to print out. So let's make a simple list here just to illustrate things, to make it clear. So maybe I have a list that's currently looking like this, and this one is pointing to null. So this is our list, and then we have some items here. So what shall we put here? Maybe we should have words that I put in here. So let's say love is a, and for those of you who know this thing, I wanted to write love is a many splendid thing, but I'm not going to write this out. So this is our list at the moment. So when we construct this class, current is being initialized to first. So in other words, first would be this one, and you should also note, if you look in this code, first is actually the instance variable defined in our queue. And in private classes, you actually have access to all the instance variables of the containing class. In other words, to the class that the private class was defined in. So in other words, I can have first and last and end available in my private class that I have over here. So current is pointing to whatever first is pointing, and so we have the situation as it is over there. And now, has next should return true if there's still an element. Now, when can we still iterate? Well, we can iterate when current, this current, is still pointing to one of these elements, but when current is null, there's nothing to print out. So in other words, we have return current not equal to null. Now remove, you can just have an empty implementation there. What we have here is what we call an exception. Probably you've seen them before. I will discuss them at some point again. So basically we just print out, well, we throw an exception saying we don't support that operation. Now let's look at next. So it asks the question, does it still have a has next? So is there still an element? So in other words, if you call next and there is no next element, it will throw an exception. Otherwise, we would say item. So that's the element that we're interested in. In this case, item is actually string. The string item is equal to current dot item. In this case, a string item would be love. And then we say current is equal to current dot next. In other words, current points to that point, to this one, and then it returns the element that you have just got. Note that we didn't remove this element. Why didn't we remove it? Well, we still have the first pointer pointing to this one. If somehow you've decided, maybe on a day after a long night out, maybe a Thursday night out or a Wednesday night out, you've decided not to have current but to use first, then, and just don't use it, you just use first everywhere where current is, then you've just written code that while iterating once over your code, you will just delete all the elements, element by element. A rather stupid thing to do, but be warned that there's something you could do if you don't use a temporary variable, in this case current, to iterate over the elements. And that's actually then indeed what there is to say about the iterator. So what does it mean? So it means if I make a queue, I can now write code such as queue string equals queue equals new queue string. So I can write something like that. So now I have a new queue. What I can then do is maybe insert a couple of elements in this queue. So I can say queue dot enqueue. Let's put something in there, friends. And I can encode another, enqueue another one, say Romans, and then maybe another one, countrymen. And for those of you who know this, we will add some others. Friends, Roman countrymen, lend me your ears. Something from Caesar, from William Shakespeare. In any case, so you add all these elements, and now I can do something for string s in queue. Since it's there, we can print out standard out dot print line s. And if this code is correct, which I hope is the case, I've just made it up now, then it should print friends, Roman countrymen, lend me your ears. Not lend me your ears, just those three. So this is how we would use iterators, and that actually concludes the topic of iterators at this point. So to conclude this lecture, I want to discuss a couple of more subtle things that we've encountered to just fix concepts. So first one, when do I use new with node? Now remember, the new operation is used when you want to create a new data type. So in the case of, for example, where you just have this particular example that we've just used of the iterators, where we have current being pointed to the same element that is in first, we don't use new there. So let me just show this example there. I say in this code, if I have to get to this situation, I would have said current is equal to first. So then they're pointing to the same block of memory. However, if I would have written, remember this is now all incorrect code, if I would have written current is equal to new node instead, what would have happened is that somewhere in memory, and now I don't have any more place on this thing, so let me just do this. So somewhere in memory, a new block of memory would be allocated for the item, for the next, and then current would actually point to this thing. And this is now of course not what we want. So new we use when we want to allocate new memory for the to insert an item, and when we just manipulate the references such as here, then we don't allocate new. The next one I've answered actually a minute or two ago. So why do we declare node as a nested class, and why private? Well, node is not necessary for the client to understand, so we make it a nested class. Now if we just make it a nested class and it's not private, it means that it's actually I think it's called a friend class, so it means that other classes within the same package can still access those nodes. In other words, ignore if you don't know the concept of packages. All I want to say is classes, files that's in the same folder as the one that defines this node class, even though it's a nested class, would still have access to node. So we want to stop that idea as well altogether, so no access to that. And for that reason we declare a node as private. So when we declare it as private, only the class defining that node class have access to it, and so we hide all the details from the client code. And then let me show you actually by doing an example. If we look at the code here, so I do a listing of all my files there, you would see I have there the Java files and I have the class files. Now let me compile, for example, a Gaussian. So I say Java Gaussian.java. If I do a listing there, you would see there's now a Gaussian.class, and this is how you would know things to work all the time. So remember, when I have implemented, if I do Java, I compile the source code to a class file being the instructions for the Java virtual machine to execute. So this is not a surprise what we see over there. So we have Gaussian.class and Gaussian.java. However, when I say Java q.java, then I get to the situation when I do a listing that I have q.java class as expected, but then I have this q$node q$list iterator class. And what are those files? Well, essentially what they are is it's the class files that's being related to the inner classes. And the convention that the Java uses is that the class files of the inner classes are q, the name of the containing class, $, and then the name of the inner class. So q$node q$list iterator. Those are the classes that we have defined there. So this is where that thing is coming from. So next question. Should a client be allowed to insert null items into a stack or queue? Now this is where we get to philosophy. Since you could argue no, you should not be allowed to insert a null into a list, or you could argue yes, you should be able to insert one. I mean, you can go and draw up a list of why you should not be allowed to insert nulls, or you could decide to allow it. In this course we allow nulls in it, but it's not necessarily that you want to do that. You could decide not to allow nulls in a container. Then the question is, are there Java libraries for stacks and queues? And hopefully my internet works at this point. There is indeed. If we look in the java.util package, and it is indeed there, then you will see that there is indeed a list. There's also a stack somewhere. I will just search for it. So there's a stack, and here you have indeed a stack with an empty, a peek, a pop, and a push, and a search. Now you could indeed, when you use implement your own code, you can definitely use the code of Java as well. So all the data types that we discuss in this course, they're already implemented as part of the Java library. So in fact, when you implement, if you use make an implementation, you can decide to use either the Java implementation or the implementations that we present in the lectures that I have, and you can definitely decide which one you want to use. However, when it comes to stacks, I would advise you against the use of the Java stack, simply because if you look at this stack, I mean, there is a number of other methods being implemented with the stacks. So I mean, you even have things like remove range, remove all elements, first element contains element add. So in other words, this stack is what people would call a so-called wide interface. So you support almost everything. And so for that reason, I mean, you could say it's a good idea to support everything, but with these things, you don't want to do that. You want to know that your particular data type can support certain operations, hopefully within constant time. You want to know exactly how it behaves, what you can expect of them. And if you have all these many methods there, I mean, it's good to have them there, but it's sort of also remove the idea of a stack. Since if you implement a stack and you always use then, I don't see an enqueue operation there, fortunately not. But if you start using elements that make a stack behave like a queue instead, then you should ask yourself, but shouldn't I use a queue to start with? Since a queue, the idea of a queue was to implement the idea of a queue, a FIFO principle, and not the LIFO principle. So sometimes the interfaces in Java can be wide as a summary. You can pick which one to use. In the case of stacks, I advise you to use our implementation, but feel free to use the Java one if you really want to insist on it. And for the other libraries, indeed, there are also implementations available. Then there's a last one. So say you want to use an array implementation for a generic stack. The code that you see over there will not compile. So what's wrong there? I mean, it looks right. So in fact, I can show you quickly what I meant. This is, let me open the queue class. So say for example, over here, I don't want to use first and last in node. I want to use instead a queue. So of course, not a queue, an array. So of course, what I do is I declare an instant variable there, private item, since it must be of the type is item array. And then in the constructor, what I will use is I would say array is equal to new item, since I want to have them of type item, and say we start with 64 elements. So we have to specify the size, of course. There. And now I compile this thing. And I compile it, java queue.java, and I get a problem there. So it says array identifier expected. So this thing is not compiling. So something is going wrong there. Now the problem what we see over there is that Java does not allow you to create instances of an array, to create arrays of generic types. In other words, generic types being this type parameter that I sent over there. So we cannot do this in Java. But of course, there's always a hack around something, and so the hack around this one would be to use instead create an array of type object. Since we can do that, remember everything in Java is an object, and then we cast it to whatever we want to have, so to an array of items. And I just hope that this works. So somewhere I have now another mistake in my code which I can't see at this point, which I will fix at some point. And then since I put it in the wrong way. Sorry, this is, I see my mistake. Let me just do everything again. I typed at the wrong place. I'm typing in the node class. Of course, this is the sad thing about making a video. I've just typed in the wrong one. It will be there forever, but at least I can fix it. So say initially I had it, this is the new code I have, but let me just write the old code. So the old code was array equals new item 64. So we have that code, that's the old code. When we compile it, we get generic array creation. Now I feel slightly more comfortable, since when I compiled this code and I saw identify expect, I did not expect it, so it was also a bit unexpected for me. This is the error I want to get. It's a generic array creation. We cannot do this. The fix is we are actually going to make an array of type object and then cast it to an item. And maybe now it is there. Now you get, of course, this unsafe operation. And the reason for that is, of course, that we've just created an array and cast it. So if we put this xlint there, it will print the warning that we have. So warning unchecked, cast. So we have a bit of a problem there. So we hacked Java to allow us now to create an array of type item. The price we have to pay for this is that we get an uncast, unchecked operation, because we do a cast and we don't check the types, and that was the reason why generics was invented for, to stop those kind of problems. At this point you can safely ignore the warning, since you know what you're doing. The warning is there to remind you, listen, you're doing something that might be a problem. If you know what you're doing, leave it there. If you don't know what you're doing, try writing code that don't do that, since you're clearly now doing something that can be in fact dangerous. And then that brings me to the end of this lecture. So I've answered a couple of questions, I've shown you iterators, and at this point you should be familiar with stacks, queues, linked lists, how to implement also stacks and queues with arrays. You should know iterators, and you should know how this memory management with the new and those kind of things work. You should also know parameterized data types, in other words generics, and that would allow you to implement a stack of strings and a stack of vans or whatever you want to do. In the next lectures we will discuss symbol tables. Remember, the symbol table is that operation, that data type that would allow you to use a works like a bit like a telephone directory. So you would be allowed to find an element almost immediately by in this data type of view, and you don't have the index operator available. Until the next time, goodbye.